Hello everyone, welcome back to the channel. Today we are going to understand Kubernetes labels and selectors from the scratch. This topic is pretty much simple. However, many people get confused. Why? Because they try to memorize instead of understanding the core idea. So don't worry, by the end of this video, everything will be clear. So basically, when we are creating a parts, you are creating one object. Not only part, but as we move in Kubernetes, there will be a different objects like pod is the object, deployment is the object, stateful set is the object, node is the object, daemon set, service, and you will have few more things. Now what will happen, it will be very difficult for us to identify a objects or group some objects. So that is where for managing those objects in Kubernetes, we use a concept called labels and selectors. Then what is a label? Basically, a label is a key value pair attached to the Kubernetes objects like pods, daemon sets, services, deployments, and so on. Think the labels are stickers that we are paste on the object. Example, app : nginx, environment : dev, tire : frontend. App is the name, nginx is the value. Okay. Since Kubernetes manages thousands of resources, labels helps us grouping and identifying them easily. That is where labels become very powerful. Then, why the labels are needed? Why? Because Kubernetes itself does not understand your application logic. You tell Kubernetes what is what using labels. Without labels, managing pods is a very major pain point, especially during the scaling time, debugging time, production issues time. So it is very difficult. So that is where the labels are pretty much important. Let's understand the practical problem first. In Kubernetes, pods are dynamic. Pod IPs change. Pod names also change sometime. So the question here is, how do you services, deployments, and kubectl identify the correct pods? That is where labels comes into the picture. So labels help us to group the pods, filter the pods, connect the services to the pods, separate environments like dev, test, prod, and QA. Despite of being simple, labels solve the huge operational challenges. Where we can use the labels? The labels can be used on pod, services, deployments, replica set, nodes, and so on. So you can attach labels to pretty much every Kubernetes object. So this is where Kubernetes becomes flexible despite of being complex. Okay.
Let's go to the practical usage of labels.
Labels are used in services to select the parts, and we can use them in the deployments to manage the replications, and we can use the labels in kubectl commands to filter the objects, and even we can use the labels in monitoring, where we can use in Prometheus, Grafana, and labels are used in CI/CD as well. That means where we can use the environment based deployment like CI, QA, and production. This is where Kubernetes becomes scalable. So that is about the label. We'll see in that practical example. Let's discuss about the selectors. What is a selector? A selector is a query used to find matching labels. Selectors do not create anything. They only select existing resources. That means selectors are how do you find it or how do you filter it. So basically, labels help you to give a unique name, and with help of selectors as a command, you will be able to exactly filter or get what do you want. Okay. So that means the simple way is labels are attached to objects, selectors search those labels. So here let's take one simple pod example, how we can apply the label for the pod. Okay. vam nginx.ml. Under metadata, we use it to define the labels. So here app : nginx. This tells what application this pod belongs to. env : dev environment information we use to define here. Here app is the name, Nginx is the value. This becomes very useful eventually when we can scale or troubleshooting something. Okay. Now let's see the relation between the labels and selectors. This is where Kubernetes become interesting. A service doesn't talk to pod names, it talks to pods using selectors. If the selector matches, traffic flows will go. If selector mismatches, no traffic. So despite of pods running correctly, wrong selector means application should be down. So let's take one simple example. So the labels we use to attach, and that has that key value format, and that will be defined under the metadata, whereas the selectors use it to find it and matching the logic, and then it will query it. The simple way is labels define who you are, selectors define who I want. Very simple, but extremely it's a powerful example. So let's watch the code, how to create the labels and how to use the selectors. So here is the code. As usual, you are using API version kind. Under metadata, we used to define the labels app:java, environment:dev. App is the name, Java is the value, environment is the name, dev is the value. Okay, and then as usually we used to define that spec. Under that spec, we used to define the container properties. Let's see. So let me execute the code. kubectl apply -f labels.yaml, kubectl get parts, and kubectl get parts -watch. See, it is running one by one, and then kubectl get parts -show labels. So see here, these are the labels we already defined in the ML file. Then we'll filter it by using the selector. kubectl get parts -l, and then we are using app is equal to Java. Okay, enter. Now see, it got matched and it is displaying now. At the same way, if we can give environment is equal to dev. Okay, now see, so it's giving me the pod names and other properties. Now what we can do, we can deploy one more part, vam nginx dot this one. Now I am deleting the labels here, 3dd. Okay, and I am saving this. kubectl apply -f nginx.yaml. So it got created. kubectl get parts. Now it is creating -watch. Let's see, let's wait for this coming up. Now it's running. Now kubectl get parts. Now there are two parts are there. One is a label demo, another one is the port mapping. So basically, when I say kubectl get parts, what was it showing? It giving me the pod names and other properties. What if I want some specific pod? That time we can use the selectors. Okay, so for that, in the command line you can use simply say -l and the name of the label. So kubectl get parts -l app is equal to Java. Now see, it displaying only specific part which had that app is equal to Java where. So let's see, app not is equal to Java mean, see here, port mapping part doesn't has the any label. Now you can apply the label after object is created. So that case what you can do, kubectl okay label pod name port mapping, then app is equal to nginx environment is equal to ci, and even we can apply one more also, version also you can apply, version is equal to 1. So that means Nginx part doesn't have the label. If you want, you can show it actually. Before applying this command, what we can do, kubectl get parts -- show labels. So this command will give labels. See, port mapping part doesn't have the labels, it's showing none. Only label demo has the labels. Okay, now what we can do, after creating the object, I am applying the labels to filter those labels. So this is the command, I am entering it. So now after that, sorry, it's a spelling mistake. So this is the command, I have applied the label. Now after that, again you can see show label, it's showing now. See, port mapping part also has the labels now. So if you want to show the label, kubectl get parts -- show labels we can give it. And then after that, what we can do, if you want to filter it, so that case kubectl get parts, and I can use L. L means it's a filtering by using the selector. Then after that, here app. So using app in, I can say Java, and even we can give the Nginx. Okay, so then if we enter, what this will do, this is the set based actually. If you want to filter it, you can use kubectl get parts -l app in Java Nginx. Okay, this will be showing both. If you want, you can do it. What if I want to delete all the parts? So this is where you don't want to say kubectl delete -f the part.yaml file. You can use the selectors for any of the commands to group or to identify particular objects of your choice. Okay, so remember that every object will have labels to uniquely identify. And if you want to see the particular part label, kubectl get part, so part name is port mapping and -- show -labels. This will shows only particular part label. If you want to see all the part labels, then you can remove the part name here. See here, it removed and it shows all the parts. So if you want to update the existing part labels, so from the kubectl command, kubectl label part port mapping, then I can use here environment is equal to prod, and here we need to put -- overwrite. So now if you see kubectl get part label, see here, earlier it was there CI, now it was there in the production. Okay, so that means using this command we can overwrite the old values. So let's see how to delete the labels. So kubectl get parts -- show labels. Now see, here are the labels available. Kubectl label part, I am giving label - demo is my part. Here I am deleting app. So if I give here app - here - means, that means it's a dash, it's a mandatory, that means it's a deleted actually. This means the object should not be deleted, only the labels will be deleted. Again, if we can see show labels, see here the labels. If you want to delete multiple labels, so you can use, say example, if I want to delete labels for port mapping, then app - if I want to delete multiple, then again you can give environment - and even version - so enter. See, you can see again, see all the labels got deleted. Okay, so this command will delete only labels, it's not the object. Okay, So now see, if you see the real-time use cases where we can use the labels, where these labels and selectors are important. Services use the selectors to route the traffic. That can be discussed while discussing that selectors. Deployments uses the selectors to manage the replicas. Okay. So here I summarize that labels are key value format. So which can be defined under the metadata section and which we can use to identify the objects, and selectors are how do you find it or how do you filter it. Okay, so with help of labels the Kubernetes will scale the objects, and without labels Kubernetes is not manageable. So if this video helped you to understand the labels clearly, could you please like the video, share it and subscribe. So thanks for watching.